All right, we're going to do a little review of rational exponents, and basically when we say rational exponents, we're talking about fractions. So recall, which means from a previous course, recall if you have something like this, the square root of x, you can rewrite that using a rational exponent. So the square root of x, that's like taking the second root, but we just say square root. So we could rewrite that as a power x to the 1/2. Likewise, if you had the cube root of x, you could rewrite that as x to the 1/3. And if I have, let's flip it around and put it on the other side, if I have x to the 3/4, well, notice how I've got a rational exponent. I've got a 3/4. Let's just kind of put this to the side here. So the top part we can think of as our power. The denominator we can think of as our root. So then I could rewrite this as the 4th power of x cubed. So let's do an example and see how this works. Let's see. Let's get a new page up here. All right, so example, quick example here. We're going to evaluate these first by hand, which means on paper, and feel free to do it with the calculator as a check. So let's do one right here. So we have -16 to the 3/2. All right, so to do it by hand, the negative is in the front, and then there's the 16. Well, the 2 is a root, so that becomes the square root, and the 3 is a power, so I'm just going to put the power up there. The negative's still here, and the square root of 16 is 4. And we still have the 3rd power, and 4 cubed is 64, and we still have the negative in the front. So double check that with your calculator. Let's do another one. Let's see. Let's do a 8 to the 5/6 all over 8 to the 1/6. Okay, so recall when you divide like bases, which means I have an 8 in the numerator and an 8 in the denominator, I subtract exponents. So that would look like this. Let's work down. So that would look like 8, and if I subtract exponents, I'm going to have the 5/6 minus 1/6. All that is my exponent. And when we subtract fractions, we keep the same denominator if it's a common denominator, and yes, it is. So subtract the numerator. 5 minus 1 is 4, so that becomes 4/6. And then I can reduce 4/6 to, let's work a little bit this way. 4/6 gets reduced to 2/3, and so now if I wanted to, I could write it as, let's see, the 3 is on the bottom, therefore that means cube root. And the 2 is on the top, therefore that means power. Let's work this way. The cube root of 8 is 2, so I have 2 squared. And when I evaluate that, I get 4. Let's do another one. Let's squeeze another one right in here. So let's do a power to a power. So I have 2 to the -2, all raised to the power of -3/2. Now you see there's negatives up here. I'm going to do an example in a video coming up where I deal with the negatives in a different way. So just right now I want to illustrate the property of a power to a power. So when we have a power to a power, we multiply. So let's just go ahead and put a little 1 under that. So I have -2/1, and I'm going to multiply that by -3/2. All this now is my power. And when we multiply fractions, we just multiply across. Negative times a negative is a positive. 2 times 3 is 6. And 6 divided by 2 is 3. So this just becomes 3. And 2 to the 3rd is 8. And let's do one more here. One more example. All right, so this one obviously you can't check with your calculator because I'm going to put some x's in here. So I have the square root of x, and I want to multiply that by the cube root of x. So I can rewrite the square root of x as x to the 1/2. I can rewrite the cube root of x as x to the 1/3. When you multiply like bases, which means these x's are the same, then you add the exponents. So we're going to have a 1/2 plus a 1/3. All that is an exponent. And we need a common denominator, which is going to be 6. So 1/2 can become 3/6. 1/3 can become 2/6. And when I add them up, let's work this way. When I add them up, I end up with 5/6. So this from the top can be simplified to be x to the 5/6. So that's the end of this video.